Welcome everyone. I will present the paper Implementation of Electric Vehicles in the Internal Route of the International University of Ecuador that has been written by Vladimir Azanza in collaboration with Álvaro Remachi, Soraya Ruiz, Gorky Reyes, and Andrés Castillo. They are full-time professors of the Mechanical Automotive School. The main motivation to write this paper has been the impact of the transport sector on the global warming. Polluting gases emissions into the atmosphere with anthropogenic activities are the most probable causes of the variation in atmospheric temperature. Depending on the magnitude, the warming pacing, the geographical location, levels of development, and vulnerability, the IPCC warns that with a global warming of 2 degrees Celsius, there is a high risk for natural and human systems with lasting or irreversible impacts. For global warming not to exceed the 2 degrees Celsius limit, it is estimated that CO2 emissions have to be reduced by approximately 25% until 2030 and equal to zero around 2070. Limiting global warming to 2 degrees Celsius increase will require far-reaching and rapid transitions in energy, land, urban infrastructure, and industrial systems. Currently, the transport sector contributes with more than 55% of CO2 emissions in Ecuador, also causing an increase in mortality due to respiratory and cardiovascular problems associated with air pollution. The life cycle analysis for electric vehicles allows to note that the environmental impacts are considering the complete useful life. Focusing the analysis only on climate change, battery electric vehicles can emit the same amount of emissions as internal combustion vehicles depending on the source of energy generation. However, if the source of electric energy comes from renewable sources, emissions are greatly reduced. Regarding electricity generation in Ecuador, this comes in more than 90% from renewable energy sources. Therefore, adopting electric mobility would lead to a significant reduction in emissions, considering that in Quito alone, the private car represents 60% of the environmental impact generated by polluting gases. In this sense, the International University of Ecuador proposes the adoption of electric mobility focused on the reduction of polluting emissions. The study is based on a quantitative approach, analyzing the technical economic variables in analyzing the different scenarios proposed to demonstrate the feasibility of the implementation of electric vehicles in the internal route of the university. The university has several campuses nationwide. However, for our study, only the main campus located in the city of Quito is considered on the area of 38 hectares at the altitude of 2,560 to 2,740 meters above sea level. The internal route connects the administrative buildings, classroom, workshops, sports fields, and parking lots of the different 11 faculties through 4 stops and 2 lanes with a length of route of 1,818 meters and an average slope of 7.76 degrees. The analysis of the passenger flow activity has been possible under the method of exploratory study and interview with the person in charge of transport of the university, which helped to know the maximum distance traveled and the number of travel cycles demanded by users, and it allowed taking actions regarding recharges, recharging points, use of extra battery banks, efficient use of transportation, and energy storage. The ideal points for the location of the central recharge in relation to the route is at the first instance the part of the highest altitude of the International University of Ecuador, this being the School of Automotive Engineering Mechanics, and other point will be in the lower part, such as the area spots. The current fleet of the Internal Transport Department consists of 2 Hyundai and Kia brand vans with capacity for 12 and 17 passengers respectively. Each van consumes 22.7 liters of diesel equivalent to $37.18 US dollars. Maintenance expenses will not be taken into account for the feasibility study, as these expenses are not charged to the university's accounting and are assumed by the transportation service provider. However, the cost for transportation rental is $2,850 US dollars per month. The electric vehicle to be considered is a motor electric vehicle with a 7 kilowatts electrical motor with a range of 85 kilometers and a battery capacity of 250 amperes with 12 batteries connected into a series of 6 volts each. Each liter of diesel emits around 2.47 kilos of CO2 into the environment. Therefore, each one of these buses emits 56.1 kilo of CO2 into the environment, emitting an approximate of 296 tons of CO2 in a period of 10 years. Among the technological limitations in the infrastructure of the distribution networks, where the high demand for electrical energy in peak hours would cause a possible deterioration and reduction of the useful life on typical distribution transformers. Thus, electric power flows will be controlled by charging electric vehicles at night. In this way, to identify the cost generated by the vehicle, the capacity of traction batteries is considered, since it depends on energy consumption. And if we talk about the Moto Eve minibus, it has a capacity of 14.9 kilowatts and autonomy up to 85 kilometers. So, if we take into account that the daily route is 178 kilometers on the identified route, the electric minibus needs to be recharged daily at night time. If necessary and according to the capacity of the batteries, recharges are required during daytime hours, so the energy demand would increase. To slowly recharge the conventional battery with a single-phase alternating current, a power of 3 kilowatts is needed. If it is observed that the electric vehicle is going to be recharged 2 times a day, a total of 12 hours at a cost of $2.26 US dollars. If 2 electric vehicles are purchased, the daily cost of energy consumption is $4.52 US dollars. Universities must develop a plan to reduce the impact generated on the environment by its growing population and the processes that are being developed, thereby encouraging university students to make a commitment to raise awareness to contribute to the control of energies that are harmful to the environment. With the implementation of an electric vehicle for the internal route, a power of 154.7 kilowatts is required to overcome a slope of 18 degrees Celsius, 18 degrees, with a route on the campus of 178.4 kilometers. With these, 29.6 tons of CO2 and 0.76 tons of gases would not be emitted harmful to the environment per year, opening the doors to sustainability, mobilizing around 2,852 users per week within the campus. Thank you so much for your attention.